Today we're at the Royal Society of Arts in London, and our guest is Professor Tony Allen. Professor Allen is Professor Emeritus at the School of Oriental and African Studies and King's College at the University of London, where he continues to teach and do research at King's College. Professor Allen is a geographer by training and has spent much of his career studying water policy issues, especially in the Middle East. In 2008, Professor Allen was awarded the Stockholm Water Prize for his innovative work on the concept of virtual water, as well as many other contributions to the water policy field. Perhaps more than anyone I know, Professor Allen has really helped us think much more critically and carefully about what it means to live in a world of water scarcity. I first met Professor Allen in Cairo in 1978, and for over 40 years we've been continuing our discussions of water policy. Tony, I want to thank you for coming. It's great to see you. It's a pleasure, as always. I thought we should start with some terminology. For our students in the MOOC, could you describe for us what you mean by blue water and green water, problem sheds and watersheds, big water, small water, virtual water? Let's get some terminology on the table here.
Yes, it is a problem in that the word which is coming into vogue now is natural water, which is another good term, but it just slightly complicates things again. So the way we can look at water in the hydrological cycle is that it's obviously rainfall, and that falls on the soil of a field, then infiltrates into the field, and natural vegetation or crops are grown with that. The water then can go further down into the groundwater, and it can also flow through the soil into the river. So we've got already a number of waters there. We'll forget the atmospheric water because we're not so interested in that, because we can't control it. We're interested in what we call the green water. That's the water that falls on the land. But hydrologists, purists of their terminology, call that effective rainfall, which I agree is a good term. It captures exactly what you mean. It's the rainfall that could produce a crop. Then the water that goes into the ground is groundwater. The water that goes into the river and the lakes is fresh water or natural water, and it can be pumped and moved. The difference between the green water and this blue water, which is the stuff in the ground, and the river, is that it can't be moved. People have to move to that water to raise crops with it, and it has no opportunity value because you can't use it for anything else, unless you regard the amenity of the environment as of value. The blue water provides many services, and therefore is much more contentious, especially if some of us humans want to use a lot of it on behalf of the rest, namely the farmers who irrigate with that water. So we have blue and green water. Blue water you can pump and value quite readily, easily, quite reasonably easily. Green water, which you can't measure very easily, you can guess from how much crop is grown, how much water is needed to grow it. So we've got, but what is clear is that the blue water, which raises food as well as providing industrial services and domestic water services, is about 30% of that is used for that.
You mean 30% globally?
Yeah. And 70% is used to raise food. So, yeah. And then that water, however, is only about 30% of the total. The water that produces crops is about 92% of the total global water. 70% of that is green water, and 30% is blue water. So the water in the other two types of water, which I need people to understand, is food water and non-food water. The food water is about 92%, and the water for domestic, industrial, those urban uses is about 8%. So what I have over the years coined is that there's big water and small water, but that doesn't mean a pejorative perspective on the water for industry and domestic. Nearly all of that is valued to some extent. You can put a price on it across the world of roughly $1 a cubic meter, although in Britain and in some industrialized countries it can be put much higher than that. But even poor countries pay for that water. So that's a small amount of water with a lot of value. There's then the 92%, which is a huge amount of water with no value. There are very few countries, in fact, price their green water.
So you mean when you say it has no value, you mean that farmers are not charged for it?
That's right, yes. Yes, it's water which is not accounted for in the price that people are prepared to pay for water. So this is one of the themes we'll continually return to today.
Right. And by big water, then you mean water that's used in agriculture, and small water is industrial, municipal. And our course really is about small water in the sense we've been worried about both rural and urban areas and how people get their water from municipal water supplies and sanitation services. So what I hope today in the interview is really to think about the links between big water and what people that are managing small water need to know about big water. Yeah. What about watersheds and problem sheds?
Watersheds are interesting and useful because to a hydrologist they define how things can happen. The water is in the watershed and that seems to make sense for them. They can work out how the water is flowing, but in practice, and therefore address it from a water science perspective, from a water management perspective. But what actually happens is that where there are problems related to water, they're not necessarily logically part of the water cycle. They're there for reasons to do with a great city being in the middle of the Thames Basin. And the Thames Basin is not as important as London. London's economy and what it does with water, but what it does with all the other things, is a much more important thing to take into account. Obviously not to water people, but what they need to understand is that politics and political economy processes relate to problems and not to just neat hydrology and water and the hydrological cycle.
Should we move on to virtual water? What do you mean by virtual water?
Well, virtual water is water that's embedded in anything that is produced. One simplifies it as far as this conversation is concerned, and generally that the vast majority of water is embedded in our food. Let's say 92% of our water that we consume each day or lifetime is embedded in the growing of the food. That's sort of coming at it from having identified that and explaining what it is. If you'd like to know how I came across the idea, it was because in my academic career, which started in the mid-60s, 1960s, I worked on the Middle East because that was the region that was the one that I was interested in and responsible for. I started doing field work there in the 1966 to 69 period, and at that time people were talking about water wars. And it seemed right. Well, if you run out of water, you're going to go to war. But I lived with that for nearly 20 years. By then, the population of the region had doubled, and there was no sign of a water war. Whereas the politicians that were handling that issue would say there's going to be a water war because it got people to feel that they were thinking about it and were going to take care of it if things got rough. And since it never happened, the experiment was it never happened. But I, as a scientist, had to explain why there were no water wars. And it was that which caused me, without planning, to encounter the explanation, which was when I was working in a library in Cairo in the early 80s or middle 80s. I spotted that the imports of food, and especially grain and flour, in Egypt suddenly kicked up in 1972. That was a political moment in the region when the Russians were being asked to leave and the US was coming in. The US had PL 480 funding, which means they were helping countries with food aid, and it meant that Egypt could import inexpensive, cheap, affordable food. So that certainly explained that there had been a big discussion about there being a water war, but suddenly it disappeared. At least, let's say that they were still talking about it, but something had changed because there was no water war. And so at that point I realized that if you got into this very serious problem of being food insecure, which could get people going, because if you get people on the streets very quickly if they think there's a food crisis, in Egypt particularly, that elemental problem was solved by importing food. It happened that Egypt and many countries were entering that, every Middle Eastern country really was entering that problem at that stage. They benefited from a global condition which was and has been for the last 200 years, but certainly for the last 70 years, there's been a progressive decline in international food prices. If you go to a person in the street and say, do you realize that international food prices are falling? They'll dispute it because, of course, the price in dollars is higher, but a user economist will know that the real or constant price is being progressively down. There have been moments of price spikes in what we call the world wars. There were, and also in the 1974-79 period, which was just before the time I was looking at these numbers. And I remember at that time thinking, well, great, the prices have gone up and then down again and then up again in 79 and then they're coming down the other side. What we want to do is just catch it and keep them going in a sensible direction. But I talked to a friend over at, a demographer and a friend over at LSE, and he said, no, the pressures in the system are so strong that they'll be coming down. And I said, surely not, surely we'll take this chance to do the right thing. And he said, no. So he was a good political economist who recognized the forces. And of course, that has happened, what he said happened, and they then continued to go down after 1980-81. In this price spike, which we've recently had from 2007-8 through to 2012, I've been constantly in a minority saying to economists who, some economists can be very naive. They thought that the world started in 2000. And if you draw the line, violence is all to do with this rise in prices. And when I said, no, they're going to come down, they just said, no, this is a new normal, is to have very volatile prices. And I said, well, no, it's not good, but the forces are still there that were there for the previous 60 years, and the prices are down. And people have stopped talking. Even the people that gave their inaugural lectures, I heard of, who preached this with all seriousness, have now started to say, no, it was not the case. And it is, the price that we have is partly technologically determined because there have been improvements in the efficiency of production. But it's still partly, and I would say mainly, because there is this inexorable wish for governments to provide affordable food and inexpensive food and possibly cheap food.
So tell us why it's a problem that food's cheap from your perspective as a water policy person. Well, I mean, most people would say that's great, right? Long-term decline in food
yes,
prices.
Indeed, and certainly a socialist system, or they got it wrong just as in Eastern Europe as we did in the capitalist West. That it looks all right, but if you stand back from history and think of labour, if you think of the capitals we have, the environmental capital and the human capital, labour and land and water. Capitalism got the human capital wrong, and from the very long time, but certainly through the 19th century. And by the end, they were starting to get it a bit more right. So the first failure of capitalism was getting labour wrong. The second one was getting the environment wrong.
Including water.
Including water. Yeah. And so not paying people enough was the problem, and paying them more and better was the solution. The same, crudely speaking, applies to the environment, that if you don't reflect its value in the output, then you're going to do, as the population goes from 10 billion to from 1 billion to 5 billion, 7 billion, going on 11, 12 billion in the later part of this century. This is a different position. That sounds crudely Malthusian, but I, as a student of water, can see that unless we change a number of things, and one of them is the price of food, we will continue to be getting the second failure of capitalism, which is getting it wrong. I used to be able to say that with confidence. The first failure of capitalism is getting labour wrong. Slavery and was in the first half of the 19th century. But I now can no longer say it because in the last 10 years, people have rediscovered slavery. And so I think we learn from that trying to get labour right is a huge political challenge. Getting the environment right is a huge political challenge, and it isn't solved in 10 years or 50 years. You've got to keep at it constantly to make sure that labour and land are properly valued.
I want to make the link with our students studying urban issues here, because I think one of the important points that I take out of your virtual water book is that these low agricultural prices have really been in part due to the destruction of local ecosystems around the world. And those local ecosystems are providing water for cities and towns and rural populations all over the world. So at first glance, it looks like this doesn't have a lot to do with our policy problem, but I mean, your point in the book is it actually really does have an important impact on our ability to supply small water to urban and rural populations in developing countries. Tony, I wanted to ask you about how this idea of, or your concept of virtual water was received by the water policy community. I mean, what was the response of people when you first came up with this idea that water was really embedded in the grain and agricultural flows, and that this was really alleviating water shortages in many parts of the world, especially the Middle East?
In the 80s, I gave a couple of lectures and also published, or the people published the paper. And I hadn't called it, I hadn't given it a name then, but I'd indicated that you could substitute. If you run out of water, there are substitutes, and there was something to do with food. And I got the feedback, not spectacular, but one doesn't expect spectacular feedbacks in the academy. I got enough to see that it was, these serious engineers and water people could see what I was talking about. But then by 1988, I started to speak about it because it's been on my mind. And we were running at that stage a series of seminars on a Monday at SOAS, and we got to talking about it. Someone had just been to Egypt and had taken the idea with them and said, yeah, it's the case. And then the term virtual came up, and I realized as a person interested in this activity that virtual was the term that would fly, and embedded, which was a much better way of conceptualizing it, wouldn't. And so I just lay back and enjoyed the discovery that we had a term which would fly. At that stage, I was busy. I was busy doing all the things that one does as an academic in an under. If we don't pay our farmers enough, we perhaps don't pay our academics enough. So as an underfunded academic, I was working very, very hard. And I didn't have time to do the publishing I should, and I hadn't been a responsible, ambitious, or hadn't been able to turn my ambition into an awful lot of publications. But I realized that I ought to capture this idea. So I wrote it up, and I had a lot of friends by then in the game. And one thing that I've discovered is that water scientists and water professionals are good people. They're easy to work with. They don't stab you in the back, and they don't steal your ideas, which is quite an important consideration. So I wrote this up and sent it off to one of the water journals, and got back a very positive referee comment from, it turned out, Aaron Wolf, who shared that with me later on, because he said, what happened to that article, that piece? I said, well, the other referee was the deputy editor of the journal, and he said the idea was rubbish. And so I said, well, if you think, I'm not going to publish with you. Well, let me tell your students, you can have extremely stupid experiences in
with the publishing process.
Publishing process. Just sort of shrug and assume that this guy was in a bad mood and didn't really, and was just letting off because he could, because it's all secret and you don't know who he is or she is. So I then left it, and I didn't then publish until the middle 90s. I thought, well, by 94 I published a piece at the invitation of a geological journal, because I found the idea flew very quickly in Israel, and they were editing that journal at the time, and so it's a 2-page piece in there is the first citable piece. And then over the next sort of 5 years I wrote a couple of articles, and then by 2000 I'd written and just got published a book which we call the Middle East Water Question, in which I was able to introduce it there. Since then I've been invited to write a number of things, and also have had to respond to a number of critiques of the idea, which started to come in by the early 2000s.
Can we talk about the critiques? I mean,
Yeah.
what kind of critiques were there, and what disciplines were the ones that were most?
The economists were the ones that, because a well-organized, trained economist is a precious thing, because they think about the big picture, and you can be doing something down here, but you need to realize that it has interactions with other things, and it's very naive, and I agree, to just think that if you're interested in water, everyone's got to take notice. In fact, water is just one of the variables, one of the inputs, one of the resources that are important in the production of whatever we produce. It happens to be hugely important in proportion to total use in the production of food. But even food is something which you should see in the bigger context. So that meant that Dennis Wickelns, who is an ag economist, and I respect highly because he's from a farming background, and we've had great conversations with common interests over this. But he then decided, we first met at a meeting organized by our Dutch colleagues who took the idea seriously, and then put metrics on for water footprints, which we'll talk about in a moment. And he attended that meeting and didn't say anything critical at that meeting, either about water footprints or virtual water, although he did begin to publish about the opportunity cost of water, and how if you take the opportunity cost of water into account, then you can be using water in circumstances where it looks unsensible from a water resource point of view, but from an economic point of view, if you're getting a massive return on that water because you're selling stuff at a huge premium across the world, then it does make economic sense. But the critique that I took most seriously was from a very good farmer friend, former politician in South Australia, where the regions I worked in tend to have been water-scarce regions, where the water issue, gets up the agenda. And he said, as a farmer, labour is always a much bigger problem than water, even in a place like Australia and the Middle East. So he said, try and get it in perspective. If farmers, and it was from him that I discovered something else we're going to return to a number of times, farmers manage volumes of water, undreamed of by someone sitting in a city where, we need a suitcase full of water in a day in the city of London, but we need 5 cubic meters of water, or 2.5 if you're a veggie, 5 cubic meters compared with a suitcase. Farmers are managing that huge amount of water. We really ought to take it into account. But he said, well, it still is the case that in practice on a farm, the farmer trying to please the bank and the taxman and whoever is somehow always finding it more difficult to find labor than they are to find water. So that was also helpful, yeah.
I'm an economist, so I've followed this debate with you over the years. It seems to me that there are a couple things that economists have to say about this problem, and my sense is you don't really disagree with them. One is that we ought to value the environment better, that we're not keeping track of the market failures on the and on the environmental side, the destruction of ecosystems and what that does to our water resources. And you make the same point in your book. I mean, I guess the other thing that I take away from this debate with Dennis and you about this is that certainly there are other factor inputs, but you've had a real impact on the political economy discussion by focusing on this one. Obviously, you can't just focus on water, right? I mean, in an agricultural system, I don't think you're arguing that in the right. I mean that you.
Yeah, I just would like it on the agenda. Yeah.
You just like it on the agenda, which and now it's getting there. So this seems to be, but I do think that it's important for people listening, our students, to as we start to talk about water footprints, that there's a difference between carbon and water footprints. I mean, can you talk a little bit about that? I mean, how? I mean, they're kind of the same jargon,
yeah.
But carbon's different than water, right?
Well, carbon, from the point of view of comparison with water, is easy. If you emit, if you have carbon emissions, they can be quantified or guesstimated. People can somehow agree internationally what they would be, and then you can get a national account, because it all goes up and it all gets mixed together. But water accounting has to take into account that water will be in the basin A or basin B or basin C, and it will be in different positions in those basins. And the way that you account for water in that much more, the impacts are very local, and they have to be taken into account locally because the solutions are going to have to be local. And so that's why they're very different. And it's wonderful to meet economists who've spent 20 years trying to deal with water. They're different from other economists. They just know that the assumptions of a generalizing economic framework, it doesn't work for water.